I first came across Neil back at Aston University, where I was a junior lecturer, and he arrived fresh from the oil fields of the North Sea to do first an MSc in pattern analysis and neural networks, and then a PhD. And what I remember about him from then was his laugh, which I'm sure will be very much in evidence during his talk, and that he, as a PhD student, sat down with my PhD student, and they co-wrote entirely on their own back a NIPS paper, which I think shows Neil's great independence of thought and indeed great self-confidence in his own abilities. Well justified, I should add, of course. So after being there, Neil went to finish his PhD at Cambridge and through various posts at Sheffield and Manchester, and worked for Amazon for a while as head of their AI, and now is back at Cambridge University. What I think is particularly interesting about what he does is two things that really stand out for me. One is his work with Data Science Africa in terms of making the techniques of data science available where they can be really put to great use, and training up the next generation of academics and practitioners in Africa. And secondly, the work he does on deployment of AI. So there are a lot of people who work in machine learning who spend a lot of their time doing just theory. And from the very beginning, Neil has been very interested in the interplay between theory and practice. And indeed, just today, I think, a report or a paper dropped on machine learning from innovation to deployment, a strategic research agenda. So hopefully we'll hear a bit more about that from him, but I think I'll stop there, and Neil, take the stage.
Thank you, Ian. What he didn't mention, he actually interviewed me for my PhD as well with Chris Bishop. And always remember that interview because I feel so strange being up here. I want to actually stand down here. I keep thinking everyone's going to fall down it, so there I have done that. I remember one of Ian's questions. This is the thing when you interview PhD students, you have no idea. Actually, and of course, Ian has no idea what he asked me. But one of his questions was, how would you solve a system of 10 simultaneous equations, probably giving it away for future students interviewed by Ian. And to which I gave, which was the right answer at the time, I said, in MATLAB. And to which Ian said, yeah, how would MATLAB do it? And I probably have told him this, well, but luckily I'd been reading a book on linear algebra on the train on the way up. And the last thing I'd been reading about was Gauss-Jordan elimination. So I sort of said, Gauss-Jordan elimination? Quite confidently. He said, I can give the appearance of confidence. And he said, yes, that's right, thank you. And I thought, nice. So always read linear algebra textbooks on the train on the way up to your interview. It's funny, and yeah, if you're interviewing with me, I do tend to ask a lot of linear algebra questions. So how great to be here. I have so enjoyed all the talks. And I think the diversity of interests, I guess it was Richard we were hearing from, where we're getting SQL going up. That's so actually really, that is, so from Amazon, I can tell you that's most of data scientists' job, writing horrific SQL things that no one else can ever understand. And it's all sort of hidden. And then also, so great to see what Dan was doing with using GANs, I think, for that representation, fine-grained aspects in climate science. But and of course, Hannah was just totally extraordinary, and I feel utterly intimidated having to follow her. So what I wanted to talk about today is this understanding artificial intelligence. And of course, there's two ways of reading that title. And I want you to think of both ways as we go through. So I'm going to start with this picture because I sort of had this notion of, it's said, I don't think he ever said this. The best quotes were never actually said by the person, but it is said that Henry Ford said that if he'd asked people what they'd wanted, they would have said a faster horse. They wouldn't have said a car. Now, he didn't invent the car, so I don't know why. He invented the production line and the sort of making a car cheaply. But that's the Model T that he's quite famous for. And it sort of provokes the question, if you ask people what they want of AI, do they just want a more intelligent human? And I don't know, because it's great fun having everyone stand up here and saying what's AI, because I'm a senior AI fellow at the Alan Turing Institute, and I don't actually know what AI is. And the reason I don't know is because I was a professor of machine learning, and I know what machine learning is, and then everyone started telling me that that was AI, but I didn't know what AI was, but that meant I was an expert in AI. So I've had to think a lot about the thing I'm supposed to be an expert in. And so some of my thoughts I'm going to share with you today. So I want to start by talking a little bit about this book. So it's a book called The Diving Bell and the Butterfly, and it's by a gentleman called Jean-Dominique Bauby. And I think it's 1993 or 4. He was the editor-in-chief of the French Elle magazine when he suffered a brain stroke. And it destroyed his brainstem. There's a film. I've not seen the film. I kind of like sounds like I've only read the book. I haven't seen the film. I've not seen the film, but I have read the book, and it's his autobiography. So the stroke destroyed his brainstem, which meant that he didn't lose his ability to think, but he lost his ability to move. In fact, he was left with only the ability to move his eyelids, and one of his eyes had to be closed for medical reasons. So I think he could only wink his left eye. And this is a picture of him, because the remarkable thing about this book is, so I think that's left eye that he can wink. And this is his assistant, who is, I think, taking down when he's winking, because he wrote this book after he fell into this state. And we tend to know this state as locked-in syndrome. So it's a really, really interesting state, and I think it holds a particular fascination. It certainly does for me to think what it feels to be like that. And the sort of beautiful thing that Bauby says is that the title of the book, The Diving Bell and the Butterfly, and I think in French the word diving bell, well, I think it's I think that the connotation of the word in French is actually one of those diving suits that Tintin wears with Captain Havoc. Sorry, dating myself there. And the idea is that he only has this communication with the surface through this one link, and that's how he feels sort of claustrophobic in his thoughts. But the butterfly is this other aspect. Oh, look, a fly just went right across it, just at that moment. A butterfly is this other aspect of his ability to sort of think freely from those thoughts and go into his imaginations. And he writes about that, the sort of things he thinks about. But the remarkable thing is he wrote this book after he became locked in, and he winked the book. And that's interesting because we can use that to have a think about his ability to communicate. So next to him is Claude Shannon, who's known as the father of information theory. Shannon, he did lots of things on the coding theory, but one of the things I think that was quite radical that he did is he came up with a theory of information where information was separated from its context. So the idea being that we could talk about information and how much information we could send across a communication line without talking about what the information was about. So I could sort of say that if the probability of Sheffield United beating Bristol City is 0.5, of course it's 0.8 or something, but just for the sake of this, 0.5, and then we know that Sheffield United win or Bristol City win, then what Shannon said is that you gain 1 bit of information from that knowledge. So also from a coin toss, if I tell you the result. It doesn't matter whether you care about Bristol City or Sheffield United or the result of the coin toss, you've gained 1 bit of information. So what's nice is that he also estimated the amount of information in English, and in the English language, he estimated that each word contains about 12 bits of information. And Bauby, in the book, it talks about how long he took to write the book. And what you can work out is that Bauby communicates at about 6 bits per minute, which is quite a slow rate of communication. Actually, if you know what you're doing, you could come up with more efficient ways he could have winked and gone faster. But that's how, if we look at what he actually did. But what I want to do is compare that to the computer and the humans. So if I'm speaking at a good rate, about 100 words per minute, it turns out that I'm communicating at around 2,000 bits per minute, right? Which is quite a lot more than Bauby at 6. But the real point is that if we go to a computer and we look at their communication rate, so I've put billions, but if it's a 1 gigabit per second communication wire, which is what's plugged into this machine at the moment, that's 60 billion bits per minute. Now, you might not be very familiar with bits, and as I think Awaz was saying before, money is just data. So let's translate that into dollars. So $6 per month would be quite a low level of pocket money if I were to pay my children that. That wouldn't be very much. $2,000 is probably not far off what PhD students are on, a bit less. So it's survivable on your own in terms of their stipend. $60 billion per month is way more than the wealthiest person on the planet is earning. And actually, it's closer to the sort of budget levels you're talking for national budgets in terms of running the whole of the NHS, doing the whole of social care, buying a quick computer for the Met Office down in Exeter. Can't resist this. Having a few drinks in Downing Street. And et cetera, with change left over for stadiums, Olympics, whatever. So it's like on a different scale. It's unimaginable. So my point is that we're much closer to Bowlby on this scale than the machine, right? So we're about 2.5 orders of magnitude out of where Bowlby is. And then we're, 6 or 7 orders of magnitude away from the machine. So we're way closer in terms of our intelligence to Bowlby than the machine. Now, you might think, okay, but what does it mean? So locked in isn't just about how we can communicate, it's how many thoughts we have. Well, when I first wrote this slide, I was estimating, and this is based on flops, obviously, or maybe not obviously, but that's what I based it on. So a typical machine maybe is 100 billion calculations per second nowadays. Maybe it's a bit faster now. Whereas a human, now, I don't know how many flops a human has, but I found some estimates of how big a machine it would take to simulate the brain, which is obviously not the same. But those estimates led to you would need about 1 billion flops to do that. And from memory, that is not the new machine in Exeter, but the current Met Office machine in Exeter is running at about that, to spend the mornings doing our weather, as we heard from Dan, and then the afternoons doing climate simulations for the future. I think that's how it works. Cambridge isn't a Met Office partner, so I probably don't really know. But 1 billion calculations per second, roughly, is to simulate a brain. So I think of this, I translate this to something I call embodiment, which is if I had a machine and it wanted to tell another machine everything it had thought, so everything it had calculated in just 1 second of time, and it wants to tell these are all the things I've thought, in inverted commas, just meaning all the calculations I've done, it would take about 20 minutes for one machine to tell another if they had this. So I'm just getting a phone call on my watch. Isn't modern technology wonderful? 20 minutes to communicate that 1 second of information. Now, if we do that for a human, and of course I don't have access to this, but if I were to try and communicate every neuron firing under this simulation approximation to you, it would take me about 5 billion years to do 1 second's worth of neurons firing. So I think most of you would have left by then, and probably people wouldn't be worrying about climate change anymore because the Earth would be in an utterly different state. Probably humans wouldn't exist. Now, what does that mean? Well, in practice, that means that one of the ways that we communicate is we bring an enormous amount of context to communication. I love this illusion. I first saw Nick Chater, who really has inspired me a lot in aspects of how to think about cognitive science and human thinking. First showed this in a joint cognitive science machine learning summer school we organized, I think, back in 2012. And it's this illusion, or supposed illusion, from 1944. So this is early days of sort of animation, isn't it? And the idea is you're watching these different shapes, and you can look at these shapes, and you can have a sense of the emotions in these shapes. Right? And the point is, but they are just shapes, that they don't have emotions. And of course, we saw that with Echo Borg last night, that we do, there the idea is to put a human in front of a machine to enhance this effect, to make you believe that actually this human thing's going on behind when it's actually an AI. Here, this is the opposite way around. There is a human behind this artificial system, and you are looking at it thinking, oh, well, the big triangle's mean, and actually these two are excited. Oh, now the big triangle's angry, or they're hiding, and all this sort of stuff. And of course, they're just shapes. They're not real human beings. But the animator has a storyline in mind when they're doing this, and you are understanding that story by watching this. Now it comes up with, normally, fortunately, I know on someone else's machine, unfortunately, they don't have any dodgy interests. So the only thing it's come up with is recommendations for other Heidel and Simmel videos, which is great. So might have to make sure the mouse is in the right place. Probably just advanced. No, it's out of focus. There we go. So what does that mean for human communication? Well, what I think is really interesting about that is when you think about how two humans communicate, we rely on this ability to understand context and to think of other humans. So if I'm communicating, and this is one-way communication, but let's assume we were having a conversation. So the first thing I would do when I'm having a conversation with someone is I have to have in mind who they are, what they know, right? Because instead of communicating everything I know, all I'm going to try and send is little differences, little things that I think will switch them into the understanding I have. So I need that, and then I make a choice of what to say based on who I think that person is. Of course, that person then has an understanding of who I am, and then they may have an understanding of who they think I think they are. You can only do this so many times before it gets quite confusing. But I think this level probably happens. I don't know. I'm not an expert. And then they receive this message plus all this additional context, and they use that additional message to sort of say something, but they need a clarification because it's not quite the right information. This is a really beautiful process because it's utterly reliant on who we all are. It's also reliant on other things that are beyond us, so our culture, the way we expect other people to behave, and the way we expect people to behave in different societies. And so humanity is really at the core of this. And of course, it's like a dance, I think, a beautiful dance when it's going well. And we exchange information. And when you're thinking like the type of information we might be exchanging, these could be two doctors sharing their understanding of a complex patient case. And of course, they're doing it well. They're sharing an enormous amount of information and learning from each other. So if we do it badly, we end up with asterisk-style swearing. And that often happens. My experience, so as people will know, even from dinner last night, I can be quite argumentative, which is not a great characteristic. But very often, I think that arguments arise when there's a slight misunderstanding of who the other person is or what their motivations are. So you don't have arguments with people you don't understand at all. You have arguments with people who you respect. Well, me. I have arguments with people I respect, and I want them to understand the thing that I'm thinking, and I don't understand why they're not getting it, and that frustrates me. And very often when you get to the core of that argument, and it's like an argument between a machine learner and a statistician about whether or not they should be applying linear regression in this case, for example. Well, but the machine learner has different objectives than the statistician. The statistician's often trying to understand the data, the machine learner's trying to improve the predictive power. And that's the source of the argument. But you really have to step away from things to understand that. So that it can go wrong, and we can have these sort of interesting arguments. But it's so much dependent on the context, I feel. Now, think about this in the case of the computer. This is very hard because you have a sense, and I have a sense of what a computer does in my head, and I'm a professor in computer science. But is it really how a computer's operating? I mean, this whole point about the computer bandwidth is trying to show you how different it is, because people don't tend to think about that the basis on which it's making decisions is utterly different to the basis on which another human is making decisions. But sometimes, like we saw with EchoBorg, those decisions can appear human-like. So it's very difficult for us because we don't actually have the right understanding about how to interact, and we end up with the so-called computer says no effect, which is basically that it's extremely difficult to weight the information that's coming from the machine unless it's somehow representing something we're familiar with in a way that combines that with the other context you understand, right? So I think that that's a real problem we face in AI, and well, in just, I don't know, I'm AI. In computers, data, and humans in society, which is what we're really sort of worrying about, data science, is how to weight that type of information. Because this machine has all this sort of access to all these really cool things. I mean, here's my favorite, another apocryphal quote. So apocryphally, Ernest Hemingway, because if you're doing novels, you have to claim it was Ernest Hemingway, wrote this 6-word novel. Now, I don't think there's any evidence he did, but the notion is that within these 6 words, there's an entire story. For sale, baby shoes, never worn. Now, you cannot follow or understand that story unless you understand human context, unless you know what that means. And that story will mean different things to each of you according to your life experiences. So that context is incredibly important, and it's missing from the machine. What I also find interesting is the way that when we're interacting with the machine, and Tati had this earlier, we often think of the Terminator. We often embody the machine. Like all the articles at the beginning of the launch of AI had the Terminator at the top. And it's totally bizarre because what we're doing is taking this entity that is not embodied. It is not embodied because it can communicate instantaneously with other entities, as far as we're concerned, relative to us. And we're putting it in a body. And we're doing that because we can't conceive of the notion of an intelligence that is outside a body, or we find that difficult. I mean, another example would be if you go to the Sistine Chapel and look up at the middle, you'll see an image of God creating man, right? Or should be humans, but in that case, it's a really languid Adam going, oh, create me, or something is what I think he's thinking. In the book, it says that God breathed into his nostrils. I don't know why Michelangelo didn't depict that. That would have been far more interesting than touching in that way. But it says breathe into the nostrils. Anyway, so when you're thinking of even religion, and if you read religion is actually quite sophisticated. I'm not religious, but religion has really interesting perspective on this external intelligence and what it means. And in I think, sophisticated religions, it becomes very introspective of what it means to be us. But in a simple way, people still draw a sort of bearded figure to represent this intelligence, which we're told is nothing like what we can imagine. Omniscience and all this sort of thing. So there's this sort of tendency to take these intelligences and put them in these bodily figures because that's how we feel we want to interact with them, because that's closer to something we can understand. But the thing we're creating is nothing like us, right? It's not like that at all. I mean, sometimes I sort of say, well, you've got 2 intelligences in your body. One is your brain, or 2 main intelligence, and that's a centralized intelligence. The other is your immune system, which is a distributed intelligence, and super complicated as well, right? I mean, I don't know which we understand less about, the immune system or the brain, right? They're both extremely hard to unpick, but the people don't think about that. I mean, and you're not even aware of it until you get a runny nose, but it's constantly operating, it's much closer to the sort of thing we've created around AI today than our brain is, I would argue. I mean, we could have that argument. Maybe we will later. But let's just establish if we're machine learners or statisticians before we start the argument. So what all this is leading to is, I think, this very interesting evolved relationship with information. So in the past, I think, when you look at classical statistics, there's this quote, lies, damn lies, and statistics. That quote is that's accredited to Disraeli. Disraeli never said that. All my quotes, no one ever said. But Mark Twain credited it to Disraeli in 1904. So before the establishment of mathematical statistics, lies, damn lies, and statistics. And actually, a lot of this interaction between data and humans is problematic because you've got this narrow bandwidth channel. And classical statistics has done an amazing job of helping us mediate that narrow bandwidth channel and understand when data can mislead us, right? And that's why statisticians, I mean, so Hannah was talking about David Spiegelhalter, and if you are interested in this, just read Art of Statistics, where he goes more into that detail. It's just a wonderful book in teaching you about how you control this bandwidth channel. I just think it's the quickest way to an understanding of data, I think, that you could find. But this is the new situation. We've now got the machine interloping. I like the fact that interloping and interpolating are very close, but interloping and interpolating between the data and then presenting to us on this new channel. And my argument, and we're here, and I'm so excited to see the Jean Golding Institute and to read like Jean Golding's history and all the hard work she's done on the 90s data, this is where we are now. So classical statistics is worrying about this. We have this problem where we've still got that narrow bandwidth channel and the overinterpretation in this corner here. But we've also got this thing where there's a very high bandwidth between the data and the machine, and the machine is adding to the complexity of how so classical statistical techniques we're having to do, as we heard from Torti, about all the things we have to do to explainable AI, or someone's put a GAN in here within the climate model and all this sort of things going on. We've now kind of trying to mediate that. Really difficult, exciting. The possibilities are amazing, but it's also why it's a slightly different. Of course, it uses statistics, but why it's a slightly different field and is worthy, I think, of a new name, data science. Okay, so what does this all mean for us? Well, I think that the interesting thing about this is, and one of the things that interests me is that while we are worrying about these consequences of these things now, we can actually go back quite a long way and see that people have cared about this for an amount of time. So I've briefly forgotten I think it's 1983 or 1984. This is the Convention for the Protection of Individuals with regard to processing of personal data. So I think it's 28th of January, I'm pretty certain of that. This is the first so-called Data Protection Act. Now, I really don't like the name data protection. Data does not need protecting. It is not a vulnerable entity. And you can see it's a horrific contraction of what this act is saying. So this is the Council of Europe, Convention for the Protection of Individuals with regard to processing of personal data. So we're not protecting data, we're trying to protect individuals. And you can read this act, and those that follow, and the change isn't that dramatic. The change is actually in GDPR recently is, which I like to think GDPR should stand for Good Data Practice Rules, not General Data Protection Regulation. Because it just says things like you should be able to explain the decisions your system makes, which seems like a perfectly reasonable thing for a good system to do. Or you should be able to show that your system isn't discriminating against characteristics which should be nothing to do with the conclusion of the system, right? So the sort of things, the provisions in the GDPR, I kind of look at them and think, well, that's kind of good software engineering or data engineering practice to conform to those things. The fact that companies can't do it is showing how difficult data science is currently. So I think there's a lot of interesting things in the GDPR that are actually giving us these individual data rights. But the question is, how does that manifest in terms of modern decision making? So there's a lot of interest in machine learning at the moment in fairness. And I've thought a lot about that interest. I mean, I don't work so much on it. But a lot of it is inspired by these sort of notions that you see in the GDPR, that you shouldn't be discriminating on the grounds of sexuality, race, medical condition, gender. I'm missing at least one. Those things are things we should not be discriminating on the basis of. And if you are involved in decision-making, consequential decision-making is, I think that's the term they use, you cannot use an automated system to do that. So actually what happens in practice when we're making consequential decisions, like offering someone a job, or offering them a place at university, or giving them insurance terms, we are subjected to these rules, and they are saying, in the GDPR, look, you can't discriminate on the basis of the fact that this individual is from a particular race, because we accept, as Totti was saying earlier, that that the AI is misrepresenting truth because of historical, all sorts of problems there, not just historical. I don't even go into it. So that's a sort of important notion of fairness. Now, I think this notion of fairness in machine learning, I think it's being implemented in a really coarse and problematic manner. Because very often people then show, oh, I can prove that my model is not discriminating on these so-called protected characteristics. But by doing that, and they're often using simple models, relatively simple linear models, they will also be introducing new categories of discrimination that they're not aware of, because they're not currently listed as protected characteristics. But people on the margins who we don't yet recognize are being discriminated against will be discriminated against. This is an incredibly complex process that there's more sophistication than I'm representing in the machine learning debate. It can't be distilled into a couple of statistics I can compute on my model, right? And I think that one of the things about it, so for example, we know these systems are going to make errors, right? Now, people are obsessed with consistency in their output of their system. That tends to be what they optimize for. So let's say these systems are going to make errors, and those errors are going to be of the form that some people have the wrong decision made about them, right? Now, would we prefer those errors to be consistent or inconsistent? I think we would prefer them to be inconsistent, so that we know if they're consistent errors, that's creating a new category of discrimination, right? We would prefer errors to be inconsistent. But if I tell you I'm designing machine learning systems to be inconsistent about their decisions, you'll all be up in arms. I tell you what, though, humans are inconsistent in our decision making. Right? So you present to two experts the same nuanced data, they will give different decisions. You go in front of a judge in the same day with similar facts in the case, they will make a different judgment. That turns out, I think, to be critically important in society to ensure when we are making errors, we're not making them consistently on a particular group. So there's an enormous amount of nuance and complexity in this notion of fairness. I call that n-fairness or normative fairness. It's sometimes, I think, called substantive equality of opportunity. But on the other side, I think there's a very different notion of fairness, which we are ignoring, or a lot of us are ignoring, which I think of as p-fairness. It's sometimes called procedural fairness. I think of it as performative. But this is about, it's fair because we all understand the rules. So this is the fairness you get in games. So that, like, the referee doesn't get to invent the rules of the game of football because they feel sorry for one team. Right? So it's clear what you have to do to win. It's clear what you have to do to get into university. It's clear how you have to do all of these things. Now, then, those rules have to be simple. And they have to be things that everyone can understand. I actually ended up talking about this with a colleague, Carl Rasmussen, who I was running with, and I was talking about the need for complexity in fairness. And he was saying, oh, no, there's this interesting situation on the Danish-German border where people are like, registering their cars in one country, living in another country, and there's some tax loophole, and everyone's upset because some people are not paying less tax, and it's a big mess. And all they did is they just introduced a new simple rule, right? It didn't matter whether it was who it was unfair or fair on. It just meant everyone knew what to do in order to minimize their tax bill, right? So a complex tax code is unfair. A simple tax code is fair. But a complex tax code is nuanced. So this is a really difficult thing to resolve. And my argument is that almost all decision-making that is consequential is having to struggle between these two tensions, and that we're nowhere near working out to resolve this. In fact, I look at this and I think that's impossible to resolve because this requires complexity, this requires simplicity. But there is a marvelous resolution. What is the most complex thing in this room? Human brain. Do humans think other humans' brains are complex? No. It's the thing they have the greatest intuition and understanding for. So the way we resolve these situations in practice is we include humans in the loop. And hopefully those humans are well trained. And I loved what Hannah was saying, as I said before, about bringing a diverse group of individuals together. Convening humans together in the right way and teaching them the right set of circumstances allows them to make good decisions. Of course, we often don't do this. There's many ways we don't do this. But the marvelous resolution we have is we include humans in the loop. And humans are involved in consequential decisions. And there's some point at which, you know, in an interview process, there's a sort of statement at which, you know, and then the panel will deliberate and make a decision, having absorbed, you know, and hopefully spent a lot of time making sure that their unconscious biases are suppressed, but they're going to have a discussion. And that discussion will be of the form, if there's two equal candidates, they'll understand the human history of those candidates and, you know, what they may have had to done to get into that interview. And they may not voice it. There's a really interesting thing about the extent to which you want that decision-making to be voiced. So transparency, everyone says, isn't that brilliant? Well, actually, I'm not so sure. Deliberation of these decisions, sometimes it's better not to have transparency about every aspect, which is a difficult aspect too. But that is definitely, so for example, the Monetary Policy Committee, unlike SAGE, people don't run out of it and then say, I said this in the meeting and everyone ignored me. And that's kind of important in the functioning of that committee and was problematic, I believe, in our scientific advice. So that's an extraordinarily difficult thing, and I would argue that you just can't have machines resolve this. It's never going to happen. Never going to happen. Because AI doesn't understand us and cannot understand us in the way we understand each other because it is not subject to being part of the human condition. So it could never feel that. That's something that you cannot do. So I think you always need humans in the loop, and I think that this is true. I mean, it's true that there are certain situations where we can have reflexive actions and all these sort of things, and we've got our biases in, and maybe we can get machines in to make it more efficient. And then there's reflective actions in terms of what we would like the world to be like, right? In terms of, yes, this is how I'm reacting now because I've been forced to make a decision. But then there's this sort of, where do we want humanity to be? And one of the problems we're getting at the moment is AI is driving us in a reflexive direction and not in a reflective direction. What we want to do is empower humans with the capabilities that AI have to see all this data. And I mean, this is really what this meeting's about, I think, because it's what all these discussions are about, empowering domain experts to use these new tools to deliver better solutions. As I say, I've thought a lot about what people seem to mean when they say AI, and this is my best conclusion, and I think it's a fallacy. So what I call the great AI fallacy is when I see people thinking about AI, it seems to me that they think that AI is the first generation of automation technology that is going to respond to us instead of us assimilating it. Right? So all previous generations of automation, and AI is just automation of decision-making. We've got other examples of how we automated decision-making in the past, and it's just bringing into reach new approaches to automating decision-making. All automation processes in the past required our flexible intelligence to adapt to the rigid, unflexing nature of the way the machine chose to do things. Whether that's gathering in the same place to feed thread into weaving machines or to feed wool into the spinning jenny or whatever it was. I used to love cycling in Sheffield because you go down to Cromford, see the early factory system. Utterly changed society. Whether that's the fact that trains arrive at certain times in stations, so you suddenly have to have a national clock instead of all going, oh, where's the sun? I'll get up now. In order to deal with the fact that we're not allowed to cycle on motorways. It's always humans adapting to the autonomous system. And I see that's not changed. We're just going to have more of that, only this automation is encroaching more and more on personal domains. So I call that the great AI fallacy, that people think somehow we've created something that's going to be more human-like. We absolutely haven't. We have no idea how to create that, I think. Our design approaches of optimizing particular characteristics do not give us that. And if AI isn't going to be a tool for us, then I think we are becoming the tool of AI. And that's what Echoborg was really talking about last night, wasn't it? I mean, whether we're aware of it or not, the extent to which we're being driven by these decisions that are taking place in the background. Of course, it's an explicit example when you have a script from an AI to read out to you. And what that means for me is that we need to get better at ensuring this is a tool for us. And of course, it is difficult to understand. But my sort of analogy, and I was talking to Chris earlier, who did aviation technonics for it's the Typhoon. I was getting the name, the Typhoon fighter. Like, no pilot is actually directly flying a Typhoon. There's all sorts of computer jiggery-pokery going on in that Typhoon to control that aircraft. But there's a model in there where, from the pilot's perspective, it's somewhat similar to a Spitfire. Or any other plane where things are actually wired up. These analogies which give you the feeling of control in all the important ways, even though that control is being assisted and empowered. And that's the sort of thing we need to do. But it's kind of quite difficult very often to see what that looks like when we don't have that analogy of the Spitfire. It's like suddenly we've got Typhoons, and we're like, oh, what do you do with that? And of course, we're saying, well, let's just have it fly itself. So what are we doing about this in Cambridge? And I think that, I've been so impressed with the Gene Golding Institute and everything that's going on here, very, very inspired by it. We've got a couple of programs that I just want to briefly mention and then give us some time for questions or discussion. The Accelerate Science program is a program that is trying to empower scientists with an understanding of machine learning. I want to be in that situation where no one talks about AI, just like no one talks about the computer, that it's just used naturally by people because, of course, you would use a neural network or linear regression or whatever you want to call it to solve that problem. And everyone knows that. You don't have to make a thing about it. And this is about trying to get to that position as rapidly as possible. That's the goal. No one talks about this. We don't get funding anymore. No, that's not the goal. And it's just a natural part of the processes of life. So the Accelerate program. Another big agenda is, as Ian said at the beginning, and we just released this report today, is what we call auto AI, which is actually trying to look at the challenges that businesses face when they're trying to deploy AI in practice. Because many of those challenges are not the sort of things, people have talked about things here, which has been really great. But in like NeurIP's papers, people don't talk about the real problems you face with deploying things. They talk about some fancy algorithm that they just spent $10 million training on AWS, which is fine, and maybe that's interesting, but it's actually not useful for most businesses most of the time. So this is a big project we have, and it's certainly not supposed to be exclusive to us. So the reason we're publishing a strategic research agenda is to say, come and join us, work on these type of problems with us, create a community around it. Data trusts, which are institutions for empowering people with their data. And then finally, I think that, so we also recently published the end of April, with, in particular, Jess Montgomery, but with a sort of discussion across the whole of the University of Cambridge. We've published a vision for AI in Cambridge. Now, the point of doing this and publishing it is that I think loads of aspects of this vision are more universal than Cambridge. And we've listed 9 challenges in there, that some are specific to the Cambridge circumstance, but many are the type of challenges you're all facing. And the aim of this document is to kind of describe that landscape so that we can all understand where it is worth investing in research. Rather than, I mean, it is great. I love large language models. They're very, very interesting. But to a large extent, putting all our dedication on that is actually not going to help deal with the type of societal problems that we'd like to resolve with AI. And with that, I'm not going to show the conclusion slide. I'll just say thank you.
Thank you very much, Neil, for a really, really inspiring talk. So we have almost 20 minutes, 15 minutes for questions, something like that. So 15, all right. Is that all we've paid for? 5 minutes, all right, sorry. 5 minutes for questions. Better be good ones and quick ones. Dima. I think we're just about first.
Thank you very much for the talk. I like the fact of this understanding and misunderstanding between humans. So you say something, and hopefully, if you're doing it well, 4 people will understand, 4 might not, and then 2 might start swearing. You don't think we're getting to the phase where we will get 4 models that will understand us, 4 won't, and 2 will start swearing?
Yeah, it's an interesting question. And it's interesting because large language models are not providing that personality like when they're responding to you. They're providing something which is very difficult to know the origin of, that's some kind of mixed up human response. So I kind of would prefer it if we were going that way, because it would show that there's a diversity of models going on. But I think everything's driving us towards one model to rule them all, which I think is highly dangerous because it basically undermines our autonomy. I mean, we're diverse for a reason, because it's good that we make different decisions given different data, because, I don't know, when an asteroid falls out of the sky on one group, they may have seemed like a good decision, but they're gone, and it's important that some of us were doing something else at that time. And my instinct is to say, well, it would be cool if that were happening, but I don't think there's anything forcing that to happen. I think it's going the other way.
Thanks. There's a question at the back.
Hi, thanks. Immune system intelligence is something that sort of struck me when my daughter got diagnosed with a primary immunodeficiency, and I suppose I've got 2 questions. One is if you've got any recommendations of what I could kind of read or watch to find out more about that, and the other is whether you think kind of sentience is a useful concept to sort of examine immune system intelligence with.
Did you say? So I missed the word sentience. Did you say?
Yeah, sentience. Yeah.
I think it's so interesting because these words are a bit difficult because they mean different things to different people. But I think that what you're saying, what I would interpret as sentience there is that the immune system doesn't sort of centralize and sort of have an aspect where sentience is, I think, the bit of the human brain which thinks it's in charge of the brain but isn't. And I think that what's going on with a lot of, I don't know what word we want to use for it, consciousness, the butterfly, let's call it the butterfly, right? In Bowlby's thing, I think it's a counterfactual simulator. So a counterfactual simulator is meaning that I have a way of exploring possibilities that are against the facts of the world, like climate model. I can look at counterfactual simulation. I can switch variables and see what would happen. And counterfactual is key because in order for it to be counterfactual, then it's not pinned down to the actual circumstances of the planet. And this whole thing about becoming obsessed with models and then hitting the reality of the world, I feel is that, of course, our counterfactual simulations tend to be overly simple. Now, having spent all that saying that's how I interpret this word sentience, which people might have different interpretations. I just don't think that the immune system has one of those, because I think it's more reactive. But it might do, and there's like interactions between the immune system and the brain that we don't understand. And I don't know a good reference to read on the immune system. Most of what I've picked up is by having the fortune to meet lots of really clever people who share their knowledge. But if anyone else does, I would also like to know a really good book on it, yeah.
Thank you.
Question here at the front.
So I found your first point quite interesting. This distinction I thought you were trying to make between classical statistics and data science. But to me, it seems like classical statistics is a tool for data science. It's something that data science should use and build on. But I'm not sure why you're making a distinction between the two. I couldn't get my head around it.
I give the analogy of like when the paperless office, everyone thought, we're not going to need paper. I mean, Xerox did this whole thing, like what's going to happen, and they try and invent the GUI, like in the 1970s. And what actually happened is we used more paper than ever before because more documents were passing around. So classical statistics I see as a massively vital tool for a lot of data science, and it's going to be key. And I think we need to understand it more and more across more different areas in making some of these decisions. I think also Hannah mentioned work by Matthew Salganik. He's got this amazing book, Bit by Bit. Have people seen that? That is a sort of handbook of computational social science. And I think that you're seeing a lot of really interesting work in social science where people want to make use of this new data. I call it happenstance data to differentiate it from surveillance data and observational data, the sort of data that's just kicking around because it's being collected now. It's a very different form of data, and it means that different techniques are needed to deal with it. But what Matthew does really well in that book is sort of shows how those techniques need to be tied back into classical sampling and surveillance techniques. And a classic one would be during the pandemic, Peter Diggle, who's up at Lancaster, did some work with the Zoe app in trying to sort of understand where the disease was. But that work was calibrated by having rigorous surveillance data from, I can't remember, either the ONS or the, is it the REACT study, isn't it? The REACT study or the Imperial study, I can't remember which is which now. And weighting that data in Wales where he had access to both those data so that you could make a wider prediction based on that self-reported symptoms, which is quite a different type of data, across England and Scotland using that linked data in Wales. And that type of thing is really, really interesting. And it sort of requires quite a deep, I mean, Peter Diggle is an internationally famous statistical epidemiologist, so he can do these things. But that type of technology is going to have to be more widespread, and that requires a deep understanding of how statistics works, not just how to compute p-values.
Yes, question back in the middle.
Hi, thank you for your talk. I really liked what you said about how we need simple and a balance of simple and complex rules, and it reminded me of how in a lot of models we include noise. To quote you, you said we have to face the uncertainty head on. But what I wanted to hear your opinion on is how equity comes into this, where less represented minorities have to have, or some people say that less represented people have to have more opportunities to kind of counter for the challenges they already have in place.
Yeah, I think it's a really important point, and I think it's very contextual. And I think how society feels about that for different decisions will vary over time. And that's why I kind of feel that that should constantly be within the Data Trusts Initiative as well, which I didn't talk about, is an effort to give people back control over their own data. So an example of one of the pilots we're funding is a coastal community in Brixham, right? So coastal communities, and there was this recent report by, what's the chief medical officer? I've forgotten his name for the moment. The chief medical officer. Chris Whitty. Chris Whitty had this recent report on coastal deprivation, and many of you will have been to coastal towns across the last summers because we couldn't go anywhere else. And the nature of deprivation in coastal towns is quite different from, say, the nature of deprivation in a town like Rotherham or Doncaster, right? And these groups, I mean, they often don't actually fit within a lot of these categories because they aren't necessarily racially disparate from the wider population. But there are particular decisions we're making centrally that have highly negative effect on these groups, whether it's Rotherham or Brixham. Now, the Brixham project is about building a data trust to take control over local data with the aim that you represent that community through how you present that data and who you allow to access that data and when you allow that access. Now, it's a sort of, this is obviously a very complex thing, but the idea there is you're allowing bottom-up empowerment to take back control because the data is giving the AI control. And if you return the control of that data to the community, then, hopefully some of this stuff should happen more naturally rather than the top-down way it's happening now, which could also be problematic. Now, having said that, it's probably a sort of very middle-class, data-aware perspective that people are going to have the time to get involved with such things. Most people don't care. So whether that will actually work in practice, we don't know. But I'm excited by that type of initiative where you're empowering communities to regain their voice. Because what's happened is they've lost their voice in very large platform companies. Even the government doesn't have a particularly great voice in some of these companies. They can't get Mark Zuckerberg to come and give evidence to Parliament, right? So what does that mean? Or if we go into, in the case of Facebook, where, yes, they're doing a lot of misinformation on the English language, but they're not doing misinformation on, low-resource languages. The Myanmar, I think there's a big problem there in terms of how these genocides are emerging. Similar situation to Rwanda, but happening on Facebook in languages that they don't resource well to understand when misinformation is spreading. So I think the only answer to that, and what I see with all these answers, is empowerment of people. Everything I'm kind of working on at the moment is empowering with knowledge or control of their data to try and give that back, that control. Which is my sort of long answer to your question, because the short answer is, yeah, it's nuanced and really difficult, and we have to think carefully about it.
Okay, I'm afraid we have to call the session to a close now, so let's thank Neil again for his excellent talk and interesting answers.